In this lecture, we are going to prove two important relations of numerical analysis relating to difference operator. Okay, and we prove one by one. The first one is u0 plus nc1 into u1x plus nc2 into u2x square to so on. This is equal to, we have to prove this 1 plus x whole to the power n u0 plus nc1 1 plus x whole to the power n minus 1 x into delta u0 to so on. Okay, now we use here the relation, important relation between shift operator and forward difference operator, which is given by E. This is equal to I plus delta. Okay, and we starting the proof from the right side, and we already here write the right side of the above relation. This is the right side. Now we first taking common u0 from the right, we get this relation as this is not d, this is delta square, and we write into u0. Okay, we are taking common u0 from the right. Now we write this series again. This is x delta. We take this x delta as a one term, and we write this is also x delta whole square and so on. And clearly this is the binomial series of 1 plus x plus x delta. So we write this is 1 plus x delta, this is delta whole to the power n into u0. Okay, because here we start from nc1, nc2 and ncn. Okay, and this can be written as 1 plus x into 1 plus delta to the power n into u0. And obviously 1 plus delta means E. We put here shift operator. This is 1 plus x into E whole to the power n into u0. Okay, now we expand this series again using binomial law, and this is given by 1 plus nc1 into xe plus nc2 into xe whole square to ncn xe whole to the power n into u0. Okay, and operating u0 we get this is u0 plus this is nc1 x into e u0 plus nc2 x into e square u0 and so on. This is ncn into x to the power n e to the power n u0. Okay, and using the result as e to the power r u0, this is ur, we write this term as u0 plus nc1 into x u1 nc2 into x square u2 and so on ncn into x to the power n u1. And clearly this is the left hand side as given, and this is LHS. This is a very simple proof using separation of symbol. Now we go to the second proof. In second relation, we have to prove u0 plus xc1 delta u1 plus xc2 delta square u2 plus so on. This is equal to ux plus xc1 delta square ux minus 1 plus xc2 into delta to the power 4 ux minus 2 and so on. Okay, here also we use this relation, and we start from the right side. We already write the right side of this expression. Okay, and we write the right side as ux plus xc1 delta square into, we write this is e to the power minus 1 into ux, because we know that the property of shift operator, this is ux, so this is ux minus 1. Similarly, we write the second term as delta square this is e to the power minus 2 into ux, and so on we write. And this relation can be written as 1 plus xc1 delta square e to the power minus 1 plus xc2 delta square e to the power minus 1 whole square. We write here delta square, this is not delta square, this is delta to the power 4, and so on, and we taking common ux from the right. Okay, and clearly this is the binomial expansion of 1 plus delta square e to the power minus 1 whole to the power x into ux. Okay, and this is given by e to the power minus x into e plus delta square whole to the power x ux. Now put here delta, this is equal to e minus 1 or e minus I, and getting the result e to the power minus x into e plus e minus I whole to the power 2 to the power x ux. And clearly this is e to the power minus x into, this is e square, this is minus 2e plus e, that is minus e plus 1 whole to the power x into ux. This expression can be written as e to the power minus x into 1 plus e into e minus 1 whole to the power x into ux. Okay, and this is e to the power minus x into 1 plus e into e minus 1, this is given by delta, so this is delta to the power x into ux, right? This is the result. Now we expand this series again in binomial series and getting the result as e to the power minus x into 1 plus, this is xc1, this is delta e, we can write because e and delta commute each other, plus xc2 into delta square e square and so on into ux here. Now we operate ux, we get e to the power minus x into ux plus xc1 into delta e ux plus xc2 delta square e square ux and so on, right? And this is given by, again we operate e to the power minus x, so e to the power minus x ux plus xc1, we get delta, e to the power minus x into delta into e ux plus xc2 e to the power minus x delta square e square ux and so on. Okay, and this is clearly u0 because ux minus x, this is u0, this is the first term of left side, and the second term is xc1 delta, this is e to the power minus x, we write into, this is ux plus 1 because e of ux, this is ux plus 1, shifting 1 times. Okay, and the second term is xc2 delta square, this is e to the power minus x into ux plus 2 because e square ux, this is ux plus 2 and so on, and write the final result as u0 plus xc1 delta, this is u1 because this is e to the power minus x and this is ux plus 1, so we write here this is x plus 1 minus x, x cancel out, that is u1, so we write directly here u1. Okay, and similarly xc2 into delta square, this is u2 and so on, and clearly this is the left side of the given expression. Okay, this is LHS, so our proof is complete. right? This is very easy proof, and we proved this relation using the separation of symbol. Okay, thank you for watching.